So our next speaker, his name is Kelsey Hightower from CoreOS. He's like the chief developer advocate. He's so awesome. And yeah, that too. And currently working on the etcd project in various capacities and then wear a lot of hats at CoreOS. So welcome your next speaker. Okay, so what I'm going to do is give you a community update on etcd, right? So luckily, a lot of people have given you a good overview on what etcd is. So I'm not going to demo etcd in a simplistic case. So the overview of etcd, number one, etcd is a database. Gonna let it soak in. A lot of people so this is like a GitHub culture for sysadmins now. Like you see something on GitHub, you install it in production, and then you read the documentation later, right? Don't do that with etcd. Etcd is a database, so it produces stateful data, right? You have to actually back this data up if you want to be able to bring the cluster back to life in a reasonable amount of time. So a lot of people get in the trap with etcd of putting it in a auto-scaling group. And it's actually really hilarious, right? Like auto-scales, and then you start losing these nodes like Walden showed you, and eventually you'll have just a new set of nodes, and all the old ones are gone, and your cluster will just stop working. And we always find this out on IRC. So don't do that. It's a database. And specifically, it's a configuration database. So etcd's original design was to provide a central place to store configuration values. So the model that CoreOS brings you is the ability to deploy your apps with this abstraction with the container. And one thing that frees you from is doing things like logging into a server and running yum install your application, right? Now you have this little bit more portable abstraction for deploying your app. The last thing for most people, or one of the biggest hurdles, is like, well, my configurations are still stuck on the server under etc application name. So one thing to kind of level up from there is to store your configs, even the whole config file, as a key inside of etcd. So this gets you one step further to me, like a modern 12-factor, right? 12-factor apps talk about deploying apps in a certain way to make them a little bit more portable and agile. To me, etcd takes it a step further from just environment variables configuring your app to some central store with consensus so apps can actually communicate with each other for configuration data. The nice thing about etcd and what makes it so attractive to people, as you've seen in some of these demos, is the automatic failover. Not a lot of databases have good automatic failover. Most of them have zero automatic failover. So when people see this in etcd, they jump for joy and they attempt to use etcd for everything. No. Don't do that. It's a really good configuration database. And it's highly available. And in the context that we're speaking about highly available here, if you lose a node, let's say you have a 3-node configuration, takes 2 nodes to have a quorum there, we lose a node and we can continue to make progress. For those that read white papers, you would know that's a way that the cluster will allow you to continue making writes while one node is down, right? So the RAF protocol helps us a lot there. So a lot of people like those features. So that's the goal of etcd, configuration store, and it has the primitives for building things like a lock service as well, since we have this consensus going on. So here's the primary use cases for etcd. And these are things that I think are important for everyone to know why CoreOS ships with etcd by default and allows us to do a lot of cool things with the operating system that we haven't really seen traditionally in the past. So one of those things is a lock service. So one thing that you see shipped in all CoreOS systems is a tool called Locksmith. And what it does is it gives us a way to coordinate cluster reboots of your systems. So a lot of you did raise your hands that you had experience with CoreOS. CoreOS will search for its updates. And when it finds an update, install those in the background. And then so we don't bring down your whole cluster and make everyone's pager go off, we try to coordinate those reboots to do them one at a time. So etcd provides all those facilities to allow us to build a tool like Locksmith. We don't have to put the logic in that tool. We can reuse etcd. The next thing is configuration data. A lot of people try to stuff, I don't know, 10 gigs of data in etcd. You won't have a good time. The current version of etcd was designed to be a configuration store. In our minds, we had this idea that you would probably have about 100 megs of data in your cluster for configuration purposes. So all those things under etc, hence the name, etcd, would move into this centralized key store that had consensus. We didn't expect people to try to push ISO images into this thing. And things like that happen, so we had to slap them on their hands. So there's a reason for this. The initial implementation was solved to do that use case, so we chose an in-memory implementation of our backend, right? It made sense at the time. Now projects like Kubernetes have come along and decided to use etcd and kind of blurred what configuration means, meaning anything that we have in our application we want to store there. So we think some configuration makes sense, mainly things like your job configuration. So if you have a scheduler, it needs to store configuration for that particular job. And if you're scheduling lots of things, there's a chance that that's going to be really, really high. And we'll talk about what that means in our roadmap in the future. But right now, the current things that we think are using this pretty much in line with our current vision for etcd was things like confd, which pulls config files from a central store and writes them out to disk so you can continue using them the same way you can. So a lot of applications aren't ready to change the way they load configurations. Some apps want to look on the disk for its configuration. So there's a bridge tool that will pull it from etcd, watching or polling, and put it on disk for you. Things like Fleet, Flannel, and Kubernetes, they use etcd to store its configuration data, whether it's your job data. In the case of Flannel, the route table for all the nodes that are up on the network. This is how it shares that configurations with the other nodes. And it kind of gives you this feel of real-time configuration. So a lot of people with experience with configuration management tools, Puppet, Ansible, Chef, those are more like a push model. You have some 30-minute polling thing. In this model, you kind of get to the world where when your app comes up, it can watch etcd in a very specific key space for application changes. So imagine having 1,000 web servers that need to have their database password changed, ideally at the same time. Using something like etcd, you can write that key in one place, and all the watchers will be notified that there's a change based on the index that they started watching. Pull that new config, and if you've written your application code, reconfigure itself. And then leader election, right? So one key thing that this exposes is the ability to have multiple things that share a resource and have them race for a particular key. And the patterns that I think Brian talked about earlier, there's a shared key, TTLs. If a node dies, that key will expire, and then someone else is free to race to grab that key. We saw this in the Compose IO demo earlier about how they do this to make Postgres highly available. Those patterns exist in etcd, and there's a lot of projects using this for leader election. This will happen in Kubernetes. Fleet is currently using it now, and we're starting to see other people build things on top of that particular model. So I'm going to give you a quick update on the project status. So etcd 2.0, as many of you know, shipped in February 2015. And this was a big milestone release for us. We rewrote the entire RAF implementation. So the Go RAF was our initial RAF implementation. And it was early. A lot of people read the RAF paper, and everyone in the world built a RAF implementation. Raise your hand if you built your own RAF implementation. Melissa, you did in marketing? Oh, wow. Awesome. So a lot of people did do this, and we rewrote it to actually facilitate more data being pumped through etcd to meet some of the use cases we're going to talk about in a second here. The next thing we've done with the current project is the new Discover, or the current Discover IO is now running on etcd 2. This is a big achievement for us. We wanted to run it in our production environment before we asked you to do the same. So before we throw it in the image, we wanted to see it, this is true dog food. So it's been running there for a couple weeks now, and we're pretty excited about it. So we'll see in our roadmap that there will be a version of etcd released, and I'll give you some timelines. We've also moved to rolling with releases, all right? So our plan here is to do bi-weekly bug fixes. So every 2 weeks, whatever bug fixes are ready on the master branch, we port them to the stable release of etcd. Today, that's version 2.0. And then we'll port those and ship whatever is ready at that time. We're also going to have a goal of shipping monthly features. So anything that's a feature, and we'll see in this roadmap, we're going to try to ship monthly for you. And so far, we've done this 2 or 3 weeks in a row. So we're happy to tell people about our process, right? It's easy to talk about it. It's another thing to do it. And we've had 2 successful releases in a row. So look for that going forward. And we're actually posting that stuff to the mailing list. So if you haven't been in the mailing list in a while, it will be a lot more active with updates on etcd. The roadmap. So this week, what we're doing this week is shipping etcd 2.05 in the CoreOS image, right? So there's been a few bug fixes since we've announced. And that should happen this Thursday if everything goes right. It should show up in the etcd channel. There should be a blog post to go with it. On the short-term roadmap in the 2.x series, 2.1 and 2.2, there's a couple of things we've discovered. So what we have now is two integration environments for etcd, right? We have these nice GCE clusters. Since we have to be ready for production stable at the same time Kubernetes will be ready around June, they really want to power GCE's cluster container implementation on etcd. So we need to do a little bit more rigorous testing. We spent a lot of time in the last few weeks standing up full integration environment, and there's a lot of testing tools now checked in the repo. We basically built a very sophisticated chaos monkey that we can control via RPC to simulate a lot of the failures you would see in a production environment. Things like network partitions, nodes going down, data directories being deleted. All those things we have the ability to start testing now. And we're starting to do that, and we're actually finding bugs. And we've started doing benchmarks in one of our other environments. And in that environment, we found that one of the biggest problems people have right now with etcd is, like any other database, it's sensitive to slow disks, right? If you have slow disks and there's a lot of latency on disk I/O, it's going to be a pain for you. So one thing very typical thing we can do, we can start batching some of these fsyncs, right? So we try to be really, really safe with your data. So for every write that you do into the cluster, we sync it into our WAL file first, and it goes into our in-memory store. And then over some configuration, we'll do a snapshot. So to improve that performance, we can batch some of these fsyncs, right? And that should improve a lot of disk I/O and relieve a little bit of pressure for people. We've also, on the branch right now on master, there's a metrics endpoint. So a lot of people have been asking us, how is my cluster performing? There are actually metric endpoints there. We plan to integrate with tools like Prometheus, StatsD, things like New Relic. We decided to implement a model where you can just poll etcd to get the metrics that you care about. Things about how much memory am I using, latency metrics, and we just started out. So if there's any metrics missing, we're happy to add those. And there's debugging endpoint. So we really want to know how our Raft implementation will perform. So we rewrote our Raft implementation, and it's also being used by a project that's very similar to Google's Spanner project called CockroachDB. I really think they should get a different name. But it's a very badass database if you haven't seen it. And they're also using our Raft implementation because they saw that it meets their needs. And CockroachDB aims to be a large-scale database here. So it's a good thing that we've already did that work in preparation for where we want etcd to go. And a big feature that we have actually just checked in a few hours ago is the etcd security, right? So there was a question earlier about how do you basically protect applications from seeing different parts of the key space. I'm actually going to do a live demo of that shortly. And then long-term, etcd 3.0, so now the vision for etcd has changed, right? We've grown past just being a configuration store. We need to be able to hold almost the entire history for some of these keys. People want to go back and see what the keys were over time. We want to hold a lot more data to fit tools like Kubernetes. Kubernetes aims to be something that can be used on nodes with 100,000 nodes in your cluster. So in order to do that, we can't use an in-memory store to do this, right? And we want to improve the current key value pair API. It works for a lot of people, but there's tons of things that we can do to make things more efficient externally for the user and internally as we add this new backend, right? I'm going to talk about etcd security. So this is the one major feature that we have that's going to ship out in maybe etcd 2.1 or 2.2. It will ship as an experimental feature so we can get feedback from people and make changes to it. So even though it's on GitHub now, if you rely on it, not our fault if we change everything. So the main purposes of our security model for what you're about to see is mainly for application isolation, right? So the current implementation is just basic auth over our HTTP API. The users and roles are stored in etcd itself, and we'll see how we make those. And the idea here is basically to protect the key space. So we don't want to build a very complicated system where people are like, read, write for this user for this specific key. Right? So we're just using things like glob patterns for parts of the key space. Based on like research and what people typically use other key value stores to do some of this stuff, we think that things like Fleet need access to the Fleet key space. Things like Kubernetes will need access to the Kubernetes key space. We don't want to turn this into a full-time job. So here's kind of what the API looks like roughly. Again, we checked it in 4 hours ago. but we're trying to do the right open source thing, check it in early, start getting feedback, and we can iterate on it. So ideally, if I wanted to list all the roles on this system, I hit that endpoint. Same thing for roles. And if you look at the keys down here, so the first key, the etcd key, is a pattern that I can give one of these roles to say that they can have read-write access to that particular key. If I want to give read-write access to a complete directory, I can use that glob pattern. So right now, that's not recursive. So that means anything under that directory at one level. And we're playing around with this idea to have this represent recursive, meaning everything under this path going forward. And then here is just saying anything in this directory and this other directory. Right? We're trying to keep the glob patterns pretty simple, and we think this is probably the right pattern for now. So let's look at this in action. Now, this has a high possibility of fail because it was literally checked in 4 hours ago. But I have a cheat sheet, right? And the good thing about this cheat sheet, since I want many of you guys to try it out, I've checked in this cheat sheet along with the slides so you can follow this demo. So I'm going to copy and paste my way to success here. And then my terminal. OK. So obviously, we need etcd to get this going. So we'll start etcd. This version of etcd is called now. All right, so it's the thing that's on the master branch right now. So I have a single node etcd cluster. I won't wow you with a multi-node cluster. But a single node cluster is enough to do what we want. So by default, when this thing ships, security will be disabled by default, right? Can everyone see that? Big enough? All right. So the next thing we want to do, and we've already come up with some use cases to improve some of this, but we want to turn on the API. So right now, we're struggling in our mind. Should the API default off, deny all requests? You can imagine if you already have etcd running in your environment and we do that, all your apps are out until you give them a username and password. So we're toying around with that. But right now, it's off by default. So here I'm going to enable it by giving it this new root user. So I have a username and password, the root user special, kind of like on a Unix system. So what I'm going to do here is I'm just going to add that user. So that user is now in the system. And it also enables the security endpoint. So at this point, etcd will reject all reads and writes to the etcd cluster for any part of the key space. Everyone's out. Now, what we're walking through now is the new case. You got etcd up from scratch. So the first thing you want to do is create a role. So what I'm going to do here is we're going to create a fleet role. And here's what the role JSON looks like right now. So basically, we have a role, and we're toying around with the permissions scheme. So read and write, and we're thinking maybe there's going to be a read-write and a read-only. So what you do is you give it the glob that you want that permission applied to. All right? So we're going to add this role now. Or we're going to list the roles and make sure there's none in the system. No roles. There's this root role, but it doesn't show up there. And then we will add the fleet role. All right. So now this role has been written to etcd. It's stored. It has permissions on those particular glob patterns. And now what we want to do, I won't list the roles again. Well, maybe. Make sure this thing is actually working. So there's our roles, fleet. And that's the permission set that it has. Right? So at this point, the fleet user, or role, has the ability to write to the fleet path. So now we need a user. So here's what a user looks like. We can give it an initial set of roles, username and password. Again, this is just basic HTTP auth here. So in real life, you're going to do this behind SSL, right? Because the whole world will have your username and password if you don't. So what we're going to do now is create that fleet user. All right? So we create this new fleet user with the password CoreOS. And its role is fleet. It's its only role. You can have multiple roles. And we'll list the user really quick just to make sure this works. All right, there's our user. Wow, off. OK, and if you notice, all these calls that I'm making on the security endpoint require the current admin privileges. So right now, that's root in my system. All right. So the next thing we want to do is actually write some data. So what I want to do is use that fleet user I created, its username and password, and create this fleet key called machine, right? So what I'll do here is use our HTTP API and do that. So that worked, as expected, right? I expect the fleet user to be able to write to any key one level below the fleet directory. All good. And then we can read that back. Again, read and write are disabled by default once you enable security. And now I can read the value because I passed in my username and password. All right, so the next thing we do, you have this user, and this user is using the wrong password, all right? And that's a good joke. You guys should like that one. And it doesn't work, right? So you get insufficient credentials, right? We're playing around with the error message because we want to tip people off like they should just keep hacking our server. But ideally, as you can see, this user can't write because it doesn't have proper credentials. So in order to fix that, well, let's look at another use case. We want to have the fleet user write to a different part of the key space. Here we just have this config path, and we want to just write some fleet config data. And this doesn't work, right? Because we've only given this particular role access to one glob pattern. This one does not match, so it fails. Everything's locked down in this case. So what we want to do is grant a permission. So you've already created this user. There's a new key space, and now you want to grant access to that. So here's what a grant looks like. We pick a role, and then we do the same thing we saw earlier when we create the role. So here I want to give read and write permissions to the config space. And the same thing here. We'll just do an update on that particular role in order to issue our grant. So here's our grant. So if that works well, the fleet user should also have read and write access to that part of the key space. And we'll run that now. All right. And there we are, it works. So that's etcd security. What we want you guys to do now that it's been committed on master, we do have a full proposal doc on how it's supposed to work, some of the decisions that we made around it. What we want people to do is pull it down, play with it. Do not play with it on your production cluster. I guarantee you, you will lose your data. I promise you, you will. So get a little test cluster, single node would do, get a feel for the API, and give us feedback so that way we ship the thing that you actually want to use in your production environments. And with that, thank you. I'll take a few questions if people have them.
When you're storing configuration values, so say if you're accessing etcd from fleet, or I was like storing environment variables, pushing those into your Docker container through fleet, it seemed like reasonable usage.
Probably not, but that's something Kubernetes does, right? Kubernetes has this ability to inject environment variables into your image before it deploys it. How you get those environment variables populated, I don't think any of those systems has this concept of go pull some data from etcd, use the results to populate some environment variables. So usually this is where we say, you know what, at that point, you probably just want to have your app start to talk to etcd if you can. And there's bridge tools like compd, and there's some other tools that try to do things like inject environment variables, but they don't necessarily integrate well with Kubernetes. Good question.
Can you elaborate on what you were talking about with etcd 3.0 and maybe going beyond just the key value schema?
So we still want the key value store, right? But we want to have people like Kubernetes really be able to push it, right? Right now their target is like 100 nodes and let's say 1,000 pods. But what they want to do is take that to 10,000 nodes and 100,000 pods, right? And able to do that, we got to be able to store that data efficiently, right? Like having all that in memory, it creates a problem for us. So we want to make sure that we can actually still the same use case, but blow it all the way out, right? So a lot of people have run into limitations with tools like Zookeeper for this very same reason that there is no disk backend. And when your data set gets too large, you just need to evacuate your data. We actually want to tackle that problem head on because a lot of the people on the etcd team sitting right in front of you, they've had experience with those particular tools. And luckily for us, we have the advantage of hindsight. We've built our model in a way that we can actually add a disk backend and improve the API and actually grow past the current implementation of etcd. So So that's what the roadmap is, just to make it really solve that use case. Good question.
So one of the usual hassles when you do these clustering systems is how you upgrade from like to V2 to V3 in a rolling sense.
Cool, so the question was, the hassle with these type of clusters is updating them from V2 to V3 in a rolling sense. We did a lot of that work in etcd, so this is why we are a little bit confident that we can push in the image. We had to do this in our own environment. We had to update from a very old version of etcd to 2.0, and we've done that work. So we have a way to migrate the database. We have a way to do in-place upgrades on the data and migrate it to the new schema set. And since we do have the high availability, we can take advantage of Raft being able to take a node down, bring it back up, and do these one by one.
So you don't convert formats until a quorum is actually running the newest version?
So I think we can actually live with the format. So there's the master, and you have the followers. And I don't think anyone changes roles. And Ichin, or Shun, could you guys stand up really quick?
From 2.4 to 2.0, I will change the internal protocol, so you need to reboot all the machines to still get it. So, but the reboot time will be very short, I guess, 1 minute in one
cluster, so the cluster goes down, or does it actually?
Yeah, it's a cluster has
so it's not a rolling upgrade.
So for the data migration, we have to stop progress.
Yeah, I guess the idea is, so you're running etcd and you want to go to a newer version, you want to have, is basically the cluster go down?
With the data migration, we have to take the pause, right? But we've upgraded from 2.04 to 2.05, and there's no data migration, we can roll the cluster.
Well, that's the easy case. But
I mean, you got a data migration, so what state will you be in if some people are using the new data format, having to replicate to the old?
The alternative is you don't change. If the new version obviously can read the old format, you don't change the format until a quorum is running the newest software.
That's one way of doing it.
But we don't.
No, we didn't do that, especially in etcd 4.6. So some of the context around 4.6 is we never really marked it production ready, but GitHub culture, people put it in production. So the things that we did in etcd 2.0, the goal now is to get people into a thing that we can actually maintain for the long haul. So when we migrate this data directory, we want people to be done with etcd 4.0. Like, we are working really hard to make etcd 4.x gone. We don't like a lot of things about it. We didn't like the Raft implementation, so it's rewritten. We didn't like the on-disk format, so it got upgraded, right? So there's things we can do to get there. It will probably be a lot more work to have them run side by side, but there's a lot of bugs in 4.6 that what will that do to your cluster, right? There's risk involved in each of these patterns, right? Maybe we had more confidence in 0.4.6. We would probably want to do something like that, but there are some bugs in 4.6 that we could trigger when we do something like this. So for us currently, we see this as the smoothest pattern for some people. We also have the ability to propagate that data to a new cluster if you want to do that. So you don't necessarily have to take the in-place upgrade if that's not what you wanted to do. And we're happy to chat with you afterwards about that. Cool.
Is it going to be required that when we roll out 2.05 in the image that you upgrade? Or is there a way to elect an upgrade path?
So this is really good. So this cluster guide, everyone should read this if they're running CoreOS and etcd. Like, seriously, you need to read this. I know planning sucks, but you need to read this, right? I think a lot of people, for demos and small environments, they put etcd on the same machines as their worker nodes, and they just deal with the whole contention problem, right? Your resources are being eaten up by your web services, causing etcd to miss heartbeats and start doing leader elections, right? That is not what you want to do in production for any database. So the reason why people do this is because etcd comes installed by default in CoreOS. So you see it there and you say, I might as well run it on every single server. That was a cool idea, and we even tried to do this standby model. It didn't work out well. And actually, it's really hard to do for a very long-running etcd cluster. So what we've done in 2.0, we made it a little bit easier to do. Something like this is ideal in a true production setup. If you don't have that many machines, then a small cluster will work fine. So when we ship etcd 2.0, both will be side by side. It will land in the image, and you have options. You can upgrade it using the etcd-ctl command to help you work through the migration to etcd 2.0, or you can just ignore it for a little while and stay on 4.6. So if you see it come out in a blog post, you don't necessarily have to run for the hills and do the upgrade. One thing we're trying to do is educate people on etcd as a database, and it's better to separate that database from your worker nodes so you don't have all this contention. So the fact that it's installed by default, yeah, sure, if you're stuck in this pattern here, you may have to do your in-place upgrade, but start to think about long-term planning so that way you can actually roll your etcd cluster and not roll it with the same nodes that you have. So there's some documentation on how to do this migration inside the etcd repository. We will do a blog post about details and the options you have when it lands in the image, right? So you can do the migration while it's there.
How many instances do you recommend per data center?
I mean, that's tricky. So like most of the time, if it's like a small cluster and your people got pagers and they run around, then 3 nodes will probably buy you enough time to figure out something's wrong, get the failed node restored, and you're back in business. 5 nodes if you're a much larger cluster, mainly for just more availability. It's not going to increase performance. So a lot of people assume I'll just run more etcd nodes and I'll have better performance. But the problem there is that in etcd, and the RAF protocol in particular, there's only one leader. And that leader's job is to take the write and replicate it to all the followers. More followers means more replication, right? It's debatable if you have more nodes, you basically wait on the slowest node for a quorum to say that the write committed. But the more nodes you have in your cluster, slightly larger the quorum is, and the leader needs to process those responses to say that the write actually happened. So for most people, think of this as more of, I just don't want to lose my entire cluster at one time. So you just keep up enough nodes to meet that. So 3 is the minimum, so we can have a quorum of 2. And if you want to grow that, odd numbers work well to 5. And if you even read the RAF paper itself, it kind of gives you some limitations on how big that should actually grow based on how the protocol was designed. And if you haven't read the Chubby paper, they also go into some detail around that as well. So not more nodes equals more performance. You just want more nodes to have some availability. So if you have 5 racks and you want to make sure that you don't lose 2 racks, you still can be good, maybe you run a 5-node cluster, 1 per rack. If you're in the cloud, maybe you run 1 cluster or 1 node per availability zone. But the idea there is just to survive failure and get yourself back up and running.
Right. So, but data center availability zone.
I would just say whatever your failure domains. So 3 is like if you lose a node, you better be on it, because 2, progress stops. 5 will buy you a lot more time, but it's silly to put all 5 in 1 rack. Rack goes down, you've lost it all. So think about your failure domains as well as how much time you want to buy yourself. Cool. I'll answer one more question, then we'll jump to the panel. Maybe 2. It looks like 3 hands went up.
Can you talk about the features of the proxy?
Yes, so I did miss that. So in order to enable this model, where we do want the idea that etcd is running on localhost on every machine, that was one great idea from the original etcd design, is that we want you to feel like etcd is everywhere and integrated to the OS. So that means all your tools can just be configured to talk to localhost. So what we've done in etcd 2.0 is there's a proxy flag. So now what etcd can do is instead of running active members on the nodes, those that partake in the replication, all they will do is just proxy commands on behalf of the clients. So that means you only have to configure one thing on the machine to talk to the etcd cluster, and then that thing will proxy commands to the active nodes. So you only have one thing to configure there. The nice thing about the proxy mode, and we have it in our documentation, the way you configure it, if you use the discovery token to bootstrap your etcd cluster, you can use that discovery token to help the proxy service find out where your etcd nodes are. You can also use DNS SRV records, which is a new thing in 2.0, and you can also give it a static list of the servers, whether those are host names or IP addresses. And it's very explicit now. Proxy mode will never attempt to upgrade to be an active member of the cluster. It's strictly a proxy node. And it also sets the stage for things in the future like caching and other things, optimizations we can make at the proxy layer and not on the etcd machines themselves. Good question.